Okay, earlier we actually looked at subroutines when I didn't mean to, but essentially subroutines are bits of code that are broken up so that you can write them separately. Remember, there's a bunch of different advantages. You can reuse them multiple times. You can package them up in a library for somebody else to use. You can split up in a team so different people can work on different subroutines. They're easy to debug because you can test them individually. So they're really useful modular programming. In this case, what we write is the word subroutine, the name of the subroutine, whatever parameter values, and whether it returns a value or not. This is simply asking you to use all this to figure out how it's going to work. You've got 4 subroutines. You've got main, which receives 1 parameter value. You've got decrease, that receives 1 parameter value, increase, that receives 1 parameter value, and is even. And these are all working together. So really, it's the skill of seeing whether you can see how they all work together here. We're going to use a trace table to see it in action. So complete the table showing all of the outputs from the subroutine call main3. So the first thing that happens is that you call main, and k is going to become 3. The first output's already been written because it says output k. You may not need to use all the rows of the table. Okay, so while k is bigger than 1, and we need to show every output. Well, k was 3, so 3 is bigger than 1. If is even k, so is even is here, so now that's going to receive 3. Is 3 mod 2, well, 3 mod 2 is going to return 1, so it's going to return false. So is that going to be false? Is going to be is false is true? Well, it's not. So that's not going to happen. So it's going to come down here. God, this is getting quite confusing already. Maybe we'll just back up a moment. So let me do it maybe with drawing some arrows to make it clearer. So that k is 3 because it came from here. Is 3, so k is 3 at this point. In fact, maybe I'll write it next to it. So k is equal to 3. While k is bigger than 1. Well, 3 is bigger than 1, so there. If is even k, so the k gets sent to is even, which is down here, and then n, in this case, is going to be equal to 3, right? Because n received what was in k, and k was 3. 3 mod 2 will return 1. So is 1 equal to 0? No. So it's going to return false. So false is going to come up here. Is false equal to true? No. So then k becomes increase k. So k is still 3. So 3 in this case, so increase, where are we increase? So n is still 3. So this is 3 times n, which was 3, so it's 9 plus 1 is 10. So result is 10. So 10 gets sent back here. So k now becomes 10. So k is equal to 10. And then it even says to output k. So output 10. Then it says, is k bigger than 1? Well, k is now 10, so that is definitely bigger than 1. Is even k, so 10 gets pent to is even. N is now 10. So we can say n is 10. Is 10 mod 2? That's going to return 0, so it's going to return true. So that will return true. And now it says k decrease by k. So k is still 10. Okay, so 10 is going to send to decrease. And there's a result of 10 div 2. If you remember, div is integer division. So that 10 div 2 means that return 5. So that will go here, and k will become 5. And then it's going to output k. So k was 5. So the next output is the number 5. Right. So 5 got outputted. Then we come back in here. Is k bigger than 1? Well, 5 is bigger than 1. So is even, right? So that's going to return if it's even, which you know it won't. So it's going to be here. So k is now increase k. So 5 goes in here. So that's 3 times 5, because, you know, k is 5, so n becomes 5. So that's 15 plus 1. Comes back in here. K becomes 16. and then you output it. So k became 16, and here it's outputting it. So here it becomes 16. Okay. And then it comes back here. Is k bigger than 1? Well, k is 16, so definitely. Is k even? So k will come down here, and you would find that 16 mod 2 will be 0, so return true. So k then gets decreased k, so 16 gets sent in here, so it's divided by 2. So now k is 8. I've stopped updating it to these ones here. It's getting a bit messy. Okay. And then we come back in here. Is 8 bigger than 1? Yes, it is. Is it going to be even? Well, it would be, won't it? Because 8 mod 2 is 0, so it's going to be true. So it's decreased by k again. Decreased by k means it'll be 8 divided by 2. So that would be 4, and then you output it. So it'll be 4. Is 4 bigger than 1? Yes, it is. Is 4 going to be even? Well, 4 mod 2 is going to be equal to 0, so it will be. So decreased by 2, so 4 div 2 returns 2, which will then output. And then is k bigger than 1? So k is 2, so 2 is bigger than 1. Is it even? It will be, because 2 mod 2 is equal to 0. K decreased by 2, so 2 div 2 will return 1 on the output. And then finally here, is 1 bigger than 1? No. So that's the end. That is reasonably tricky. Easy to get lost. Okay, this is a question where it's now combining subroutines and arrays and the concept of authentication. Remember, authentication is when a user proves their identity, could be through biometrics, but in this case with a username and password. We start up over here. In fact, I might zoom in a little bit for us to see. Oops. Just because there's a lot on screen at the moment. Ooh, hopefully that will work nicely for us. Okay, so we've got, array again starting at 0. So that will be at position 0, position 1, position 2, 0, 1, 2 for the 2 arrays. At a glance, how do we know they're arrays? Because they've got these square brackets. Line numbers are included but are not part of the problem. Absolutely. So subroutine, identify or authenticate. It's got 2 parameter values, user and pass. We've got these 2 sets. These must be a collection of usernames, and these must be their corresponding passwords. So username Dave, password ABF32. There's some stuff here where you've got a variable called z equals 0, correct is false, and then that must be the process you go through to check if they're right. All right, why don't we do the trace table together? So first thing that happens is that it wants you to check z and correct. So z is 0, so we can put that in here. And correct is false. You can see that directly underneath it. I'll point it out just in case. See, false. Okay. While z is less than 3. Well, z is 0, so 0 less than 3, most definitely. So if user equals USZ, so what position 0 on US? So that's Dave. So if user equals Dave, well, we don't know that at the moment. Oh, yes, we do. I've totally forgotten to read this. User is Alice, right? And password is woof 2006. My apologies. So is Alice equal to user at position 0 Dave? No. So terminate. And then Z is Z plus 1. So Z is going to increase by 1 or increment. Is Z less than 3? Yes. User, so Alice, is equal to US, but now at position 1. So Alice. Is Alice equal to Alice? Yes. Is pass, so woof 2006, equal to pass at position 1? Yes, it is. So correct equals true. And if Z is Z plus 1, so Z will go up by 1, so 2. And then in here is Z less than 3. Well, 2 is less than 3. So users at US position 2. So is Alice equal to Bob? No. So terminate that. And then Z becomes 3. Is 3 less than 3? No. And wow, return correct. So it would return true. Okay, let's go to the next one. State the value that is returned by the following subroutine call. So if we send Bob, there you go, and ABF32, what's going to happen? Well, the problem is Bob is in position 0, 1 in position 2, and Bob's password is this. So what's going to happen? Well, correct to set is false here. It's only going to become true if you have a match between that one and that one, that one and that one, and that one and that one, which it doesn't. So it's going to return false. Okay. Where were we? Line 7 and 8. So the if and this one could be replaced with a single line. Shade one lozenge to show which of the following corresponds to the correct new line. Now, before reading it, what we've got is we've got an if statement, and nested inside it is another if statement. The function of that is to use an and. So, because it's like, to get to this point here, this has to be true, and this has to be true. So we're looking at something with an and. Now, it's not going to be or, so that's an and command, and that's an and. If user equals USZ, yes, and pass equals PSZ, it is that one. Because this one is saying if it's the opposite, so it's going to be that one there, because both is basically saying on this argument that both would have to be true. Okay, a programmer implements the subroutine shown in figure 3, so this one. He replaces line 9, this one, with return true rather than return false. Explain how the program has made the subroutine more efficient. Now, you might have felt a bit frustrating that we'd found it true, and yet we still had to evaluate the rest of the list. Okay, that is kind of inefficient. By going return true, you'd stop the algorithm at that point, and it wouldn't continue, so you wouldn't have to do any more tests. So what you would do is that it wouldn't have to continue to check once it's found it. It would stop at that point, which would make it more efficient. So the program would return true as soon as a match is found. Otherwise, you keep having to go over the rest of the array, and so there's going to be no need to keep on checking out the rest of them unnecessarily. So you wouldn't have to check the rest of the array, and you could say unnecessarily without necessity. Okay, this is quite a long and involved question. You read a question like this, and it can actually throw you a little bit with just how much is being asked of you to understand. But you apply the concept of decomposition to try and break this idea down into more manageable chunks to be able to answer this question. To get us started, let's just start having a read. A developer wants to simulate a simple version of the game of battleships. The ships are located on a one-dimensional array called board. So that's just a list. There are always 3 ships placed on the board. One carrier has size 3, one cruiser has size 2, and one destroyer has size 1. The size of the board is always 15 squares. A possible starting configuration is shown below. So it's 0 to 14, so 15 different values. And the ones that are shaded in black here are the different ships. So that's your carrier, that's your destroyer, and that's your cruiser. Okay, for example, the carrier, for example, is found at locations 1, there you go, 2, and 3. A player makes a guess to see if a ship or part of a ship is located at a particular location. So picking a number between 0 and 14. If a ship is found at the location, the player has hit the ship at this location. Every value in the board in the array is 0, 1, or 2. So a 0 is represented to an indicate. So this bit where it's sort of white, that's a 0. 1 is if a ship is at this location, so that would be a 1. And 2 is if it's been hit. Okay. The developer identifies one of the subproblems and creates a subroutine shown. So here's a subroutine F. Terrible, terrible name. It takes in the board, so it takes in this array, takes in the location you want to hit. Board at that location, so the position between 0 and 14 is position H. And then whatever's held there, if it's a 1, that means it's a ship. Otherwise, there's nothing there. or it's already been hit. Okay. The subroutine in figure D uses the values true and false. Each element of the array board has the values 0, 1, or 2. State the most appropriate data type for these values. So even this super complicated question, it starts off actually not too brutally. So true and false, that's going to be Boolean. And 0, 1, or 2, well, that's going to be integer. There you go. The developer has taken over the problem of the game Battleships and has broken it into smaller subproblems. State the technique that the developer has used. All right, we understand this. When you have a big idea and you break it into a bunch of smaller ideas, that is decomposition, as opposed to abstraction. An abstraction was when you remove unnecessary complexity to let you focus on, or unnecessary detail to let you focus on the important pieces or the important bits. Okay. The identifier for the subroutine in figure 10 is F. This is not a good choice. We said that. State a better identifier for the subroutine. Explain why you chose it. So F is finding whether there is a boat there, right? Isn't it? Because it's saying sending the board, sending the location you want to check, and if it's a 1, it's seeing if the actual item is there or not, or if there is a if there is a ship there. So my name I'm going to give to the identifier is ship found, because I'm saying if it's found it there. What's my explanation? If ship found and unhit, because if it's hit, remember it would be a 2, return true. And if it's not hit, if it has been hit, it'll be a 2, and if it's not there, it'll be a 0. So it's whether you've actually been able to make a hit for this one here, whether you've actually managed to find a ship to hit. Okay. The variable h in the subroutine in figure 10, h, is local to the subroutine. State 2 properties that only apply to local variables. So this is local versus global. A global variable is visible throughout the scope of the entire block of code, so visible in all subroutines, while a local variable is only visible within the scope of the subroutine and also only exists whilst the actual subroutine is being called. So let's write those two down. First of all, local variable visible in scope of the subroutine. Local variable only visible in the scope of the subroutine. So in this case here, let's imagine that we had some other subroutines. H is only visible and accessible here. In another subroutine, it would not be available. So that's one of the points. What else can we say about it? Well, we can also say the variable only exists while you've called the subroutine or while the subroutine is actually running. So part 1, the local variable is only visible in the scope of the subroutine, whereas the global variable is visible throughout the scope of the code, in all of it. The local variable also only exists while the subroutine is running, while global variable is always available to be accessible. Okay, and this is the final question. So it's asking you to quite a bit here. It's asking you to understand the nature of the problem that's just been described and then implement a solution. And what it's doing is it's asking you to write a new subroutine. So we already exist this one here. We also need to develop a subroutine that works out how far away the game is from ending. So the subroutine should have a sensible identifier. Take the board as a parameter. So the array, this array here, it has to accept it as a parameter. Work out and output how many hits have been made. So you're going to have to go through the array and check to see where a hit has been made. And if you remember, a hit is stored as a 2. Work out how many locations containing a ship have yet to be hit. If there's 0, output a winner. If 1, 2, or 3, then say almost there. All right. It's worth bearing in mind as well that you start off with needing to make 1, 2, 3, 4, 5, 6 hits. So that's where you need to get to in the end to be able to make that decision. So anyway, let's start off by calling it the subroutine. So literally you write the word subroutine to declare it as being so. The next thing is it's going to have a sensible identifier. The identifier should be basically describing what it does. So what do we need to do? How far the way is game from ending? How far from ending? There you go. It's like the Ronseal of identifiers. It says what it does on the tin. Now, it takes in one parameter, which is the board. So in here, we'll write in board. So it's going to take in the array board as a parameter. All right. Next thing is we need to work out and how many hits have been made. So we're going to have to go through the array and count how many times we've actually hit, it's taken a hit. So let's declare a variable here, hit, initialize it to the value of 0. And then we're going to step through the array and look for every position in the array where the board has been 2. Since we know how many times we want to go through because we know the size of the array, we should make use of a for loop. So we're going to use a for loop. So for, we use a counter or an index. I'll use a I for index. I start at position 0. Where do we want to go up to? Well, we want to go up to the last position, which is 14. Alternative, you could say board.length -1. Either way would work for our purposes because we know it's always going to be this size. So basically, you're starting at 0, then go to 1, 2, 3, all the way to the end, you get to 14. Okay. As we're going along, we need to check the board and we need to say if board, and then to check an individual position in an array, we use square brackets. At position I, so first time around it'll be 0, then 1, then 2. If that is equal to, so remember if it's a 2, it means it's been hit. So if it's equal to 2, then it's actually should be recorded as a hit. So we should take hit becomes hit plus 1. So we've actually increased the amounts of hits it's taken, and we've increased it by 1 every single time that's happened. What happens if we haven't got a hit? Well, it's either not there, right? Or, well, I would say that at the beginning, there's 6 things that could be hit. So you could either count every time there's a 1 and say that's yet to be hit, or yet to be hit could be 6 minus the total number of hits, if you see what I'm saying. Because if the number of hits is 0, then the number yet to be hit will be, oh, I say 6. Yeah, 6, right? Because there's 1, 2, 3, 4, 5, 6. There are always 3 ships placed, size 3, size 2, and size 1. So yet to be hit would be 6 minus hit. If you've hit 2 of them, then 6 minus 2, you've got 4 yet to be hit. So that would be this. We'll just go end if. And then we'll say the for loop. The default of the for loop is it always goes up by 1 every single time. So you don't have to specify for this. Where were we? Work out and output how many hits have been made. Okay. So output. And the message was hits. So that's how many hits have been made. Might be nice if we said speech marks, there has been plus hits plus made. Anyway. And then next it says, if there are, work out how many locations containing a ship have yet to be hit. So that would be 6 minus hit. If it's 0, then output the winner. So I would say, for this one here, we could say something along the lines of if 6, which is the total number, minus, in fact, you know what? Let's take a moment to just calculate it. Let's do it separately. Sometimes there's a little less many. Yet to hit, right, is equal to 6 minus the number you've hit. Oh, poo. I called that hits. 1 second. I called that hits. So they should all just be hit. I put a plural in, which is technically the wrong thing. Okay. And we say if yet to hit is equal to 0, i.e. we've hit them all, then what? Well, then output winner. So underneath here, you'd output the phrase winner. You do exactly as they've asked. So winner. And we'll also say else if. What else could we check for? Well, we need to check if yet to hit is 1, 2, or 3. You could say else if yet to hit equals 1, or yes to hit equals 2, or yes to hit equals 3. I think it'd be easier to say yes to hit is less than or equal to 3, right? And you could then say output. Gosh, I'm getting low on space here. Output almost there. Because if it was 0, that's going to trigger first. And then if it's 1, 2, or 3, it'll say this. And then otherwise, I guess you do nothing. I should write an end if here. And underneath here, I should say end subroutine. And then that'll be that finished.